There we go. Okay. So I want to begin my day, as I am wont, with retrospective. What went on yesterday? Yesterday was a tough day for you folks. It's a tough day for me too, for different reasons probably. And I want to again express my appreciation for you bearing with it. You know, when I reflected last night on what we did yesterday, it was actually a really impressive sweep. And it bears emphasis that the material that we covered yesterday is not, you know, just foundational material that we're going to build a skyscraper on. The skyscraper is going to require much more of you. Rather, what we were exercising yesterday is the day in, day out use of sort of how, I would say, many of the, arguably most, for some models, most of the things you do day in, day out. So the skills you learned yesterday are not, you know, just beginner skills that that you're going to need a lot more sophistication to go beyond to something much grander. It's actually that combination of those skills yesterday in a clever combinations that are going to allow you to build really rich models. It's not that, you know, you've learned arithmetic and now you're going to go into calculus or something in the next few days. Rather, those skills combined together cleverly, the use of events, the use of state charts, understanding the different transition types in state charts, use of networks, building up populations, just doing that in the right way, in the right combination, can get you amazing places. There is more, it's true. We will be taking a look today at networks in additional detail. We may, during the course of this day, if not by tomorrow, certainly be looking at geographic information, drawing in GIS data, embedding these models so the agents move around in networks of streets and can go to parks, etc., which are known to be from GIS databases in their vicinity. And that's going to require some additional pieces, but actually a lot of it builds on the skills you've had. And representing mobility will require a little bit of additional stuff, but really you saw that many of the toughest things you've actually seen. And I'm trying to give you a flavor. I'm not here to pull the wool over to someone's eyes as to what's required to deal with these models. No interest in whitewashing it. But at the same time, you have to realize that what we went through yesterday is probably the hardest transition. To see this, you know, this overwhelming thing where you have these areas, these little actions you have to fill in with code. You have to put in these components from the palette, and you're not sure how they fit together. You have to create populations, and this notion of a parameter as encoding assumptions and communicating them. So you've gone through a lot of the toughest pieces. So hang in there, troopers. We're making good progress. In fact, we're making really impressive progress. Jeff tells me that the boot camp yesterday compared rather favorably to other boot camps that I previously led in terms of how far we've gotten during the day, and it's really true. If you think about it, we started in the morning with you not knowing how to even start a model, and you know, we built up a number of skills. We learned how to add a depiction of a person, a theory of personhood for the model. Remember that first time we did that? We had personhood including age, income, and sex. And we saw that we could denote sex with this thing called an option list, which denoted a set of categorical possibilities. And we saw that we could create populations of these people by dragging that class called person into main. We could create a population. And we had to frob it a little bit, but basically you could create a population. And you could size the population accordingly. And then we went on to build from there to put in place some mechanisms where we could draw from a probability distribution, the number of males versus females, for example. And we ended up elaborating it so that we could see visually people's depiction. Remember that? Red and yellow, and we could lay people out according to income. We could size them according to income. And I argue that's not merely eye candy. Yeah, it's fun, but it's not, by fun, it's not fun in a desultory way. It's not fun in a way that's dismissive of substance. It's actually substantive. It's actually the way in which we often will inspect the model and see if it's working properly, is to give it some visualization. So the skills there were not merely playing around. They were learning some skills for depicting models. Now, we saw that we could, and this is a very important point, we saw we could depict rich heterogeneity. That's not a trivial point. In fact, it's one of the foremost attractions of agent-based modeling. It's its ability to capture heterogeneity. If we have an aggregate system dynamics model, very powerful, very fond in use in my group, and they've given lots of insights, it's hard to capture really rich heterogeneity. You have to stratify it in all sorts of ways. Each stratification affects across the entire model, and it gets really cumbersome and awkward. It gets very confusing and error-prone as well. And agent-based modeling, to add a new characteristic, if we wanted to add an aspect of education to a person, we could drag in a parameter, add a little state chart. It's a very local thing. It just requires modifying that little bit of the model, and we can add this in. And we can remove it with the same ease. If we're not sure how much this heterogeneity is going to be critical, we can add it in, experiment with it, see how much of a difference it makes, and remove it. So it lends us a certain flexibility. Heterogeneity is important. But that first model that we built, ladies and gentlemen, it was recommended by many virtues, but it lacked dynamics. It lacked the primary motivator for the use of these sorts of methods. Dynamic modeling, after all. So we went back to the drawing board and we built a second model. And this model was meant to address several components of that kind of heuristic I gave you, parties, to think about pieces of an agent-based model, agent-based and hybrid model. Properties, captured in our case with parameters, things that are sort of long-term properties of an agent. And we had states as well. We have actions that change the state, things like becoming overweight, losing overweight, becoming diabetic. And we had rules under which those actions took place. Initially, the action of becoming diabetic took place after exactly 1 year of time. Not realistic, but it was the default in any logic. Remember that? And then we elaborated. We turned it into a hazard rate. It was called a rate transition. And it had a very well-defined mathematical meaning. And there's plenty of videos where I'll talk about that online. And it's probably a concept familiar to many people, but fundamentally we're specifying a hazard. And this reflected the fact that these models, by default, have continuous time associated with them. They don't go in ticks from one step to another, which require you to deal with all the things that occurred over the past year. Rather, events happen at their natural time. And if we look at that model that we built yesterday, if we were to open it up and peruse it, here it is. I will open it up. It's posted on the site for those who want to grab my particular version. We saw that we could run this model and we could see the implications of our assumptions, of our kind of theory of personhood that we articulated here. You folks did that. You folks had this little theory of personhood that you built up. No mean feat. 15 years ago, that would have required a course in computer science. It would have required a lot of effort. But we have this implications of the theory of personhood, and if we go down to the level of a particular person, we'll see that over time, this person is, for example, developing diabetes or developing overweight or what have you. And these transitions between these states are occurring at their natural times. We don't have to broker between them. We don't have to adjudicate which one occurs first. Whichever hazard rate leads to the first event occurs first. And it's a lot simpler than doing things in discrete time from that perspective. So we saw that this thing was running in continuous time. And in fact, if you go down here and you look at the bottom of the screen, you'll find time is moving on here in a continuous way. It's yes, please.
There were some screens where we actually set time as a year or a month. So what is that function do?
Wonderful question. Thank you so much for that question. That's a great issue. So let's go take a look at that. And remind me your name again?
Allison.
Allison. Thank you, Allison. So if we go to the model as a whole here, folks, and we go up here and we go look at model time unit, what does that mean? A lot of my students, and perhaps some of those in the class, initially labor into the misconception that when you specify the time unit, what it means is time set. So you're going, a year at a time versus a day at a time, right? And actually, it's not that. It's asking what our yardstick is, as it were, for measuring time. What's the unit we use when we say 1? Does that mean 1 year, 1 month, 1 day? And this is important, among other things, for interpreting that little number down at the bottom of the screen. Is if it says 10, is that 10 years out or is that 10 days out? It's also important for interpreting these rates in their default context. So here you notice this is a per year hazard rate, right? So probably per year. It's a probability density, and it says per year by default there because we specified the default units of the model as years. Now we could change this. We could make it very clear that this isn't a rate per millisecond or per week. I don't mean to be facetious about it. I mean, there are times where it's very handy to be able to say, well, the model as a whole is articulated in terms of years, but this certain rate I'm gonna prefer to express a per week rate. Sometimes happens. But that's just our yardstick for how we interpret what 1 means, what 2 means, what 3 means. It's in terms of the time unit of the model used here. And it does fill in automatically certain things, like if you do want to change this, you want to be careful about it, because when you drag in do you remember we added some graphs here? Do you remember that? We added graphs to sort of display information about our model, and you'll notice that in the updates area, if, for example, propose updating every 1 year. And if we made the default time of our model weeks, it would be updating it every 1 week by default. We could always change it, it's just that sometimes we forget to do that or not careful about it and so on. So that time unit of default for the model provides us a way of interpreting what 1, 2, 3 means, 1, 2, 3 weeks, 1, 2, 3 years. It also provides the defaults for a lot of the mechanisms we put into the model. Is that helpful? Okay, so thank you, Allison. With this model, we built up and we put these state charts in. They provided us a way with characterizing dynamics. And then we did something, well, we used multiple state charts. And this is worth emphasizing because, again, when you have a single aggregate model, you kind of have to consider all possible combinations of things. For if you're this age group and this gender and this ethnicity and this income decile, what's the implication? Here, we have the luxury of having continuous parameters, so we could actually specify someone's age or someone's birth date or someone's birth weight, and as fine a detail as we wish, which is notable. We don't have to quantize into these categories. But more than that, when we have these state charts, we can articulate them not in an entangled fashion where we have to consider all possible 3 by 2 or 6 combinations, but we articulate with different state charts. We have this separation of concerns, a diabetes state chart and a weight state chart, and each characterizes the dynamics associated with it. But ladies and gentlemen, they are not solitudes. So we had in place a mechanism to allow, for example, this state chart with weight to affect your hazard rate of developing diabetes. And we accomplished that through one such mechanism, which will allow it, this interaction diabetes and weight. It was a hazard rate term for becoming diabetic associated with weight. Do you remember that? So we had this state chart influencing this one. And indeed, we also had this other state chart on the right being influenced by age. Man, you did a lot yesterday. There's a lot going on there. A lot of different things going on that you put into place. And you should be credited for that. We had this thing called a table function. Remember that? Where we looked up, we could look up for someone's age, what the value is. We could specify it more finely, less finely. We had this kind of graphical rendition of it below here. And it's from these pieces that we built up this model. Your first model. This was actually your second model, but it was a pretty impressive achievement for a little bit. I know it stretched you. I know it stretched you far. But many classes on agent-based modeling that had people for a week never even get them to look at code. Never get them to look at what's inside the model. They talk about model building, they talk about advantages of it, and thinking about what to put in the model, etc. But it's too scary to look at the code, and they figure students won't be able to understand it. That's not my belief here. My belief is that students can understand it. But let's not fool ourselves either. And this relates to a very important point. You folks coming to the workshop, I'm not expecting you to go out and suddenly become model builders on your own. Suddenly become a model builder. After you go home, you're going to be able to go and build a model of your area immediately. Some of you may aspire to that, and some may actually succeed in that. But succeeding in this area is a matter of a team. It's not a matter of each person in isolation. I can't succeed in doing this alone. This is not something I undertake in a garage, especially in Canada, nor do I undertake it in a back office sort of way. I need to work with biostatisticians and epidemiologists and those with PhDs in public health and those who are from health economics background, and work with them to build a model that's responsive to health priorities. And for you folks too, you know, just as if I gave a week-long session on biostats, I wouldn't expect you to go out and, you know, say, well, I don't have to get a biostats degree, now I'm a biostatistician. That would be foolhardy. That would be foolhardy. So it is with modeling. There's a lot of expertise here that are demonstrated building a model, a lot of judgment, a lot of apprenticeship that's traditionally required to be a virtuoso at this. But it would be a total mistake to think you can't do this at all. If you're not going to build them yourself, you can't do it at all. My goal here is to provide you with the tools so that you look at a model and understand basically what it's doing, tease it out, maybe modify pieces of it to change it in ways that are more fitting, that you'd be able to run scenarios with it, run what-if questions, put in place new interventions, add new graphs to it so you could see data on that the main modeler didn't happen to add. But you will want to do so partnering so that on occasion you could consult with someone who's for years been trained in, you know, some of the special components required for doing the heavy lifting with models. Just like you would with a biostatistician, right? You could, if you're an epi person and you're a health economist, you could do some biostats, but there will be times you have to give your biostatistician friend a call and say, look, I've got this issue, I'm not sure how to handle it, help walk me through this. Maybe sometimes you have to ask them to do that piece of the analysis. And so it is with this. But that doesn't mean you can't use biostats at all. No, you can do it. You can use SAS or SPSS or R or Lizrel or whatever tool you use to do so a lot of analysis. It's just you need that person you can call on when times get tough. You need, ladies and gentlemen, the geek squad. Well, okay, exactly. Okay, so yes.
Can I just ask another question?
Sure.
While you've got that screen up, what is the advantage of having continuous time when you have very discrete changes in your hazard?
That's great. So only every 5 years. Well, first of all, I put these in for doing this quickly. I didn't want to drag it. You can put these in as finely as you want. Maybe during the first, and it doesn't fit well with this example, but maybe during certain critical periods you want to map things out every year, or indeed every 6 months. We deal with data from childhood, childhood obesity issues and so on. You may want to finer grain for those years, and a coarser grain for others. So maybe the first 6 months you have one set of assumptions, for the next 6 months another, and then every year for the first couple, and then every 5 years after that. And it's very handy to be able to do that, to be able to slice and dice time as finely as you want. I will also note that these numbers here are interpolated. In other words, if someone is 7 years old, or 7.5 years old, the actual rate that's applying here is 0.25. It's halfway between these. Again, particularly for cases where there are critical periods, it may be that you want that extra level of resolution. I think, Alison, that's a good question. And there is a question of how fine-grained do you need certain components of the model, like how frequently does this event go off. But I will also note that if I changed this model time unit from years to weeks to days, the impact, and this is very significant, the impact on model time that takes the time to run the model is 0. I know there's a term for it in Australia that would be used. It has 0 impact. Okay, and why is that? Because actually, what AnyLogic is doing beneath the covers is actually going from event to event. What are these events? They include things like having transitions going across. Today, we'll see messages being sent from one person to another. Events are occurring with reporting. Do you remember we added this late in the game? We added this reporting event. So if we go up to main and we scroll over, okay, now I'm going to teach you a life skill that I need sometimes. I'm going to go to main, I'm going to go to events. Where was this thing? I'm going to double click on that. That's where it was. Okay, it's up here. This reporting event, every 1 year it goes off. It just goes and handles events as they're going on from time to time. So if we changed it, we said we want to count time, we want to measure time, we want 1 to mean a month instead of a year. The numbers in the model will be different, but the actual amount of work that AnyLogic has to do is no greater. Actually, it doesn't have to do any work, and that's why if you're careful to attend to all the pieces of your model, the choice of time unit is largely a matter of convenience and mental clarity, rather than being a matter of how much work AnyLogic is going to do. There are other choices that definitely do impact the model performance, and one of them will be how often we recalculate this age-specific overweight hazard. But that's independent of what time unit I choose as kind of to interpret what 1 means. Is it a year or a month? This is it's a choice of convenience. As long as you're careful about the model, you can choose whatever you want here as long as you're convenient about it. By contrast, this choice, how frequently this goes off, every 1 year or every 1 second, will have a really big impact on model performance. I don't know if that's helpful. Comment, return for that. But it's kind of like, in summarizing, it's different from summarizing data. But, someone asked us, what's the what's the incidence rate for, childhood idiopathic arthritis in the Sydney area? We could specify that in terms of, on a per year basis, per 1,000 person years, per 1,000 person months. We could choose a way to specify it, and it's different ways of sort of pointing at the same underlying rate. I don't know if that's helpful, but that's the basic issue there. So don't think that, I'd like to make it years, but it's going to be too expensive, or I'd like to make it days, but it's going to make the model run a lot more slowly. Actually, it doesn't make it run a lot more slowly at all. It's just, how do we measure time? What's our convention for measuring time? Is that helpful? Okay, great. So ladies and gentlemen, in answering these questions, I've been also referring, not only did he put these mechanisms in place for describing dynamics at an individual level, but you further here put in place mechanisms for reporting. And some of these mechanisms were quite straightforward. So with the agents here, we went to the population, and we could define these things called statistics. And we began our baby step along that way by defining a count of diabetic individuals. And that count simply counted the number of individuals for whom this condition is true, this criteria as specified by condition. And that criteria basically said, hey, for a given person, uncharacteristically given the term item, we asked, are they in a certain state, namely the diabetic state? And that reflected the fact that they were here. We're asking, are they in the state? Count the number that are in that state. Does that make sense for what we did there? That's a statistic. And then we had another statistic that we did that actually required some work on your part. Required more work on your part. And that was this age at first obesity episode. Now this is a fairly advanced statistic. Fairly advanced in terms of what I ask people in boot camps to do. But like the troopers that you are, you folks went and put it into place. Okay? Power to you. Power to you. So what we did is we made it a default value here, and when someone first became overweight through entering this transition, we assigned it to their current age. We kind of determined if they were overweight here. That's pretty sophisticated. I wouldn't ask my entering students to do that immediately. But it takes a little bit of computational thinking here to put that into place. That may or may not be something, if you were working with a model like this, that you'd feel comfortable doing yourself. You might want to ask the primary person responsible for the heavy lifting of the model to do this, or maybe some of you would feel comfortable putting it into place. Maybe over time you'd feel more comfortable. But this is an example of it's non-trivial stuff. By putting this in place, we were able to then map it out. So in main, over here, we could look, for example, at a histogram. We had a histogram, and that histogram was based on some histogram data. It referred to this data object, and then this thing updated it. Okay, so periodically, every 1 year, this thing basically threw away all the old data, went through the population, and added each person's age at first obesity episode into this data. Wow. Bet you didn't think when you entered the room yesterday you'd be doing that by the end of the day. A lot of stuff packed into one day. Pretty impressive that you were able to hold up. So with that in hand, you've done a lot of the really hard stuff, but we're going to be exercising those basic muscles some more. Got them in place, you're building them up. We're not going to be doing anything terribly distressingly more complex, but we will be exercising these things some more. And of course, all of that followed reflections on modeling more generally. And I got the impression from comments that these were things many of you were familiar with. But I gave it a different slant than many of you perhaps have heard. Many approach models as technocratic instruments. things to be built, things from which answers are secured that advise us to the best policies. Perhaps they are built by people who are experts in this area, who consult only as necessary with others. And I gave a rather different picture for how modeling takes place. And this other picture was reflective of our practice of modeling in embedded teams, where the model is not something held close to the bosom in the back office and where people only get reports from it, but rather the model is on day in, day out, week day, week out. We share the model within team members. They look over our shoulders. They help us say whether the data seen in the model is realistic. They help us cross question and challenge the way we've described things. They help guide what should go in the model in terms of outputs, what goes in the model in terms of assumptions. They check whether the data that's in the model looks realistic to them or whether the data coming out of the model is realistic to them. In short, models here are embedded in teams, and models serve as learning tools. As Jeff put it in a very memorable phrase, they're learning prostheses. And like any prosthesis, it exists to complement our limitations. We have a crutch or we have a cane. It exists to complement, to help make up for our limitations so we can expand our function, expand what we can do in life. And so it is with models. We can't think these things through consistently in our heads, and a model helps us do that. It helps us complement our limited abilities in our noggins so we can use our noggins for purposes for which they're better put and which a computer is just not going to be able to deliver on. So models help us think more quickly, robustly, and more deeply about the implications of our assumptions, and help us check far more quickly and deeply than we could if we relied on our heads whether those assumptions add up, jibe with empirical data. They are not used in contraposition to empirical data. They help us take that data further. They help us understand more deeply the implications of that data, and they help cross-question that data, because sometimes the model has issues and sometimes the data has issues. This is a different view of modeling than you'll often hear, even from the mouths of people who've done modeling for decades, but it is a view that I wanted to provide. So that winds down my planned retrospective. Any comments, questions, dialogue we want to have about that before we get into some more fun with the model, some more use of the model? Any more questions? Concerns? Things that are troubling you? Okay. Man, you're almost as quiet as my classes back at school. Okay. Maybe you like them, don't know quite what to make of me. Okay. So, ladies and gentlemen, let's go and let's take this model and take it for a couple further steps here. Okay. And there's a couple directions that I would like to go with the model. So the first thing is, I would like to put into place some mechanisms for collecting some additional pieces of information about the model. And we're going to use some additional types of charts that will summarize that information. We are then going to go on to build in some health economics components, okay? And we're going to see a little bit about how some statistical relationships might be captured in the model. And increasingly, I am going to be asking you to tell me what to do. I'm going to give you a high-level need, and you're going to give me some ideas about how I might pursue that need with these modeling software. Okay? Ready to go? Okay. Great. Okay, so ladies and gentlemen, the first thing I want to do is I would like to go here and report on the number of people who are in each obesity category. Oh, sorry, each weight category. Okay, that's in the population. I want a population breakdown by weight. Okay, and I would propose to do it with a pie chart. What would I do? Okay, here's my model. You may wish to download it if you want to draw it. I'm going to actually save it as I want. I'm going to call it version 2 of the model so that I can upload it. And notice, most curiously, it keeps on asking me for model time units. I'm going to keep on saying years. Don't change those time units for me. I want to be clear about what 1 represents. Does it mean a second or does it mean a year? Okay? I don't know why, Jeff, we should write back to the mothership about that one. Why would I change the time unit as I save the model? Save as. Okay, and why should it be by default different? Okay. Okay, so I just saved it. What would I do? Where would I go if I want to do something like that? Good. Okay. So I'll go to the palette. And which area of the palette? Great start. Presentation? Analysis is right. And it's easy to get confused because presentation has lots of other visual things, but analysis is where the action's at in terms of some particulars here, okay? Okay, great. So we see a pie chart. That gives us some good clues. Where do we go to go and add it? In Maine. Could we add a chart to person? Okay. Good. It's because it's have to do with the population. Very important point here, though, is that these things in the palette, you can use them at the main level, you can use them at the person level, you can use many of them in the experiment. They're not, don't get in the sense that, oh, well, state charts are for a person, and you can't use them in Maine. You can use state charts in Maine if you want to have seasons, right? I guess I'm from a town that exhibits a measure of seasonal variability, and we have quite distinctive winter seasons from our summers, as well as to some degree short and beautiful, I would add, springs and falls. I guess here in Australia we have different seasons as well. And my next trip to Adelaide, I may be acquainted with the Australian summer temperatures. Last time I was there, it was 42 the day before I arrived. Okay, so ladies and gentlemen, we want to put it in Maine because it's a characteristic of the whole population. That's the key thought. State charts, lots of other things could be put in Maine as we see fit. But let's go add this pie chart into Maine, right? So let's go to Maine. There we are. Here we are in Maine. And let's put it in some place that won't run afoul of people. And let's go and put in a pie chart. Here we go. Here we go. Now, I like to be a little bit on the edgy side in terms of pushing myself. I actually don't remember how pie charts in any logic work, but I'm going to figure it out in front of me. Okay, great. This seems like a good thing to do. So let us go now call this chart. We'll call it weight status pie chart. How do you like that? Weight status pie chart. Okay? Is that okay? Okay, great. And for now, we'll leave these things as we see fit. And you'll notice that it asks for data items. These presumably are data items associated with the different breakdowns in the chart. One is led to infer. Okay, so we could probably add one of these and we'd be able to set the value for a particular pie slice. So we'll probably give it, a certain number for different pie slices. Okay, so this is great. Maybe I want this to be people who are normal and underweight. What do you think? You think so? Don't be timid. Don't be shy about exploring any logic. You can explore and try things out. This is not a chemistry lab where you have to worry about producing phosgene gas or something like that. My wife is a MD and PhD chemist, and we have different styles as to our willingness to experiment with things, including in the kitchen, I would know. And she's from a tradition of very carefully measured aliquots, and where you do not combine substances that are not normally combined to see what happens. Whereas in computer science, generally the implications are somewhat less severe. Okay. So experimentation is encouraged as a general rule. Okay, so normal and underweight. Great start. Great start. Okay, let's go add some more, okay? We're going to add another data item. We're going to say overweight. Wow, we're making good progress, aren't we? And we'll do another one. This will be, say, obese. Wow, we're feeling good. Look at that. Look at that. Okay, but what's the missing piece here? What's the missing piece? Okay, yeah, what's the value we put in there? Okay, we're almost all set. Almost all set. We got all the breakdowns. Okay, now we got to get those values. Okay, where are those values going to come from? You tell me. Where are we going to compute those values? I'll tell you. We saw it yesterday. Sorry? In where? In the states of the state chart. Good. And how are we going to count how many people are in each state? We've actually seen it before. The same way we counted the number of diabetics. That's right. Where did that live in the model? This is a lot of the use of AnyLogic. I'm saying if you're building an AnyLogic model, or if you're using someone else's AnyLogic model, you want to be able to think this way. Where would that live? Where would I count up the number of people who are diabetic in the population? It's in the population. It's in the population. If I want to count it for Sydney and count it for Melbourne, I might have different populations represented for each. Okay, so ladies and gentlemen, let's go to project, let's go to main, and let's go to the population. Right? Great. Okay, now, in the population, we will see this area called statistics. Can we add some statistics in here? Let's go add them. Right? Just like that. Okay, we'll have count, normal, and underweight. Okay? And now you tell me what to put in here. A lot of what we'll be doing the rest of the boot camp is rehearsing these things you've already done. It's revisiting rather than pushing you to new things. Yes, the GIS stuff will involve some news. Yes, the mobility. Yes, exchanging messages. There'll be new things, but a lot of it is just rehashing what we've done and reinforcing what we've done. So what do I put in here? Oh, that's beautiful. That's right, and that's exactly how you do a lot of your AnyLogic work. You model it off of something that you have. And I would note that I provided you dozens of models which have lots of pieces in there, and if you want to go figure out how this is done, you could even look at those things. Okay, so item dot instate, just like above, and what do you think we put there? Person. I know the need for that is a little bit obscure for you. It has to do with the characteristic of person. I said there could be diabetic dogs and diabetic horses and diabetic people all in the same model, so you have to say person diabetes versus dog diabetes. Okay, person dot, the name of the state. And the name of the state was normal and underweight. Now, very important point, folks. You'll save yourself an amazing amount of grief. Amazing amount of grief if you do autocomplete. Autocomplete, I know it takes time to build up friendships. And it takes time to build up trust. but take it from the instructor. Autocomplete is your friend. Use it early, use it often. I rely on it, as you can tell. I make typing mistakes. I mistake how I abbreviated it. And occasionally I'll be known to use longer names. And I could just do autocomplete and fill it out, rather than having to retype it all. Okay? Are we okay with that? What else do we need here in the statistics?
I was just going to point out that it really is not kidding about autocomplete. It's basically an indispensable tool if you're going to do any kind of programming. I know it's become such a frequent thing for me to use that it's muscle memory, and I'll find myself in, let's say, Facebook conversations or emails, or trying to write a Word document, trying to autocomplete what I'm actually saying and realizing I don't have that facility there. You come to rely on it, and it makes your work in your life just so much simpler and faster. So
Yeah.
get used to it if you can.
Yeah, and you can do it, and this is a very important point. You can use autocomplete not only for your own, the things you've added to the model, but to find out what the name of any logic's so-called functions are, how to request information. You can use autocomplete for them. And we'll say, oh, you can ask me this or ask me that, etc. For example, I'll show it when I add the next one. We're going to add another one for count overweight, right? And watch this. If you could, just watch this. Item dot, control space, and it will tell me all the things I can ask for from item. I can ask for their birth time, I can ask for the age that they were first obesity episode, but I can also ask them, for example, deliver a message to a random person. I could ask for their distance to their mother. I could ask to disconnect them from an ex-spouse. I could ask, for example, to get their color, etc. So there's all sorts of things that I can do using that, and it will tell me all these things that I can do. So that sheet I gave you will give you lots of clues, but you can also use autocomplete in this way. Okay, this is item.instate, and this is person.overweight. There was a time when I was Dylan's age, and I wore a younger man's shoes. There was a time that we all had to remember these things in our heads. And I had to go around, Dylan wouldn't believe, I had to remember, like the entire C library, remember the order of the parameters and so on, which order, store cat, which came first or what have you. And those days are thankfully past us. Okay, and for the name for the last one, I'm adding another one, count obese. Item.instate person.obese. Okay? There we go. Great. Excellent. Okay. So, we've just added these statistics. Now what do we have to do to complete our vision? What do we have to do? We've added these statistics. These are all counts. What do we have to do now? Indeed. So let's go into the pie chart. And for normal and underweight, what will I do? Based on the skills we had yesterday, what will I do? Who do I ask to get the statistics? Where do the statistics live? They live in the population. Yeah, population. So who do we have to ask to get the value of that statistic? We have to ask the... Yes, thank you. Population. Okay, populate. Okay, you can see why I should do autocomplete. Population dot count normal and underweight. Just like that. Okay? For overweight, population dot count overweight. Boom. You notice I select it with those. Let me show how to do that again, because sometimes there's multiple of them. Count, and I call that up, and then I can use these arrow keys to move it up and down, and I can press enter for the one I want. Did you see that? Are you feeling okay with that? Who would like Nolian expertise to help guide you on autocomplete? Would someone like, are you feeling a little bit confused about it? Because I must say, I sometimes get in a weird autocomplete state if there's multiple versions of this thing. Then I'm calling, I need to do, it is ... and I need to do things, okay? Autocomplete is your friend, and Dylan can help make that friendship secure.
I'll point out that there is one small hiccup for bilingual users.
Oh, yes.
If you have a language bar and you need to switch between languages, Windows' default key shortcut for that is Control Space.
Indeed.
And it will override any logic.
Indeed.
I will look for a way to change
I know it. Oh, there's an easy way to change it. I'll show you.
Oh, perfect.
Because I have many students for whom I do autocomplete on their computers, and I get into Zhongwen, I get into the enter it in Chinese, and I need to change it. Okay. So here we go. Ready? You do tools if you want to change it. Okay. You go to tools, preferences, and then key combinations. And there's this thing here, and you can change it as you see fit. You could change it to Control Alt Space, for example, or you could change it to Shift Alt Shift. Oh, you can't change Alt Shift Space. You can change it to Control Shift A or something like that. I'm going to leave it as Control Space. Okay. Okay, great. So let's go on and do this. Count obese. Okay, there we go. So count obese. Okay. So if you're having problems still with the autocomplete, just call Dylan in, and he can set you up. Again, for those who want to change it, tools, preferences, key combinations, and you go click here and you can press the combination you wish. Okay? I should have nuggetized that, Jeff. Yeah. Okay, are you ready? Okay, are we ready to run this model? Okay, let's first of all, let's do build early, build often. Okay, and then let's go. I'm trying to go at a little bit of a more gentle pace this time. Okay, now let's go up and scroll up. And you see this annoying thing where this is cut off down here? Note that you can click on these things and have certain slices of the pie emphasized. But you'll notice that it's cut off. For those who wish to, I'll run it and we'll see that, ooh, look at that. Okay, normal, and we can click again on this, and you'll see. Okay, there's some movement around between these states, but this is the number. We have a small population, so this flipping is pronounced. Okay. Okay, great. So to correct for this truncation, I'll show you how to do it. Ready? Here, what you do is you go back to this, and you can pull up this and just give it a little bit more area, okay? Or you can drag it further and then pull up if you don't want it to sort of show too much, okay? Are you feeling okay with that? Okay, great. Now, we did something else yesterday, ladies and gentlemen. We did something else of note. So now we have a nice new shiny pie chart that we can break down. Fairly simple to define. You define these breakdowns. We've told it, go ahead and update it every 1 year. It takes care of computing these things. Does that make sense? Question? Dylan? Okay. Okay. Oh, okay. Oh, okay. It's actually capital P person. It's talking about personhood, like obesity with respect to personhood. Yeah. So thank you very much for pointing that out. Ladies and gentlemen, in this population, in the stats, this is a capital P person. Okay? Capital P person, not a lowercase p. Okay? You feeling okay with that? Okay. Great. Okay, who would like another minute or two before going on? Okay, great. Okay, you notice that this thing fluttered in a most pronounced fashion. Let's go to, I'm going to go to the big population of 1,000 people, and I'm going to run it with that, and we'll see if the fluttering is abated. Okay, here we go. The fluttering here, because of the larger statistical size of the population, the fact that we have more individuals, the variability tends to be less. And we have this certain division between people who are normal, overweight, and obese. Okay? We okay with that? This is for the larger population, yeah. Okay? So we've added in place a mechanism there. That's great. Okay, ladies and gentlemen, I will ask you now to put in place some additional mechanisms. So one thing I'd like to do here is to put in place a mechanism where we're going to add some heterogeneity to these agents, because we have a somewhat dichotomous situation. Let me nuggetize this. I'm going to